Imagine a field, but instead of crops, it's filled with life. Rows upon rows of pods, each one a technological womb nurturing a human embryo. This is ectogenesis, the future of human reproduction. It sounds like science fiction, but it's closer than you think. Scientists are working tirelessly to make this a reality. Ectogenesis is the process of growing a fetus outside of the human body. This is done in a controlled artificial environment. The concept is rooted in the idea of replicating the conditions of a mother's womb. This involves providing the developing fetus with nutrients, oxygen, and a sterile environment. In 2017, a team of scientists at the Children's Hospital of Philadelphia achieved a groundbreaking feat. They embarked on a mission to address the challenges faced by premature infants, who often struggle with underdeveloped organs and face high risks of complications. They successfully sustained premature lambs in artificial wombs for 4 weeks. These artificial wombs, known as biobags, provided a controlled environment that closely replicated the conditions inside a natural womb. These biobags mimicked the environment of a natural womb, filled with a special amniotic fluid that allowed the lambs to breathe and grow as they would have inside their mothers. The lambs' lungs and brains developed as if they were in their mother's wombs. This was a crucial development, as it demonstrated that the biobags could support the growth of vital organs, reducing the risks associated with premature birth. This breakthrough signaled a significant step towards human ectogenesis. The success with lambs opened up possibilities for future research and development, potentially leading to similar technologies that could one day support human premature infants, giving them a better chance at healthy development and survival. Fast forward to 2021, and scientists achieved another milestone in the field of ectogenesis. They successfully grew mouse embryos outside the womb for 6 days, a groundbreaking achievement. This was a critical step forward. It showed that mammalian embryos could develop outside a natural womb for a significant period, paving the way for future advancements. Professor Katsuhiko Hayashi of Kyushu University in Japan is at the forefront of this groundbreaking research. His work is pioneering a new era in reproductive science, one that could redefine the very essence of how life begins. He has successfully created mouse eggs and sperm from stem cells, a feat that was once thought to be the stuff of science fiction. This remarkable achievement has the potential to revolutionize fertility treatments and offer hope to countless couples struggling to conceive. This opens up the possibility of human babies being conceived and grown entirely in laboratory settings. The implications are profound, ranging from the elimination of infertility to the potential for genetic enhancements and the eradication of hereditary diseases. Imagine a world where infertility is a thing of the past. Couples who once faced the heartbreak of infertility could now experience the joy of parenthood. This technology could democratize reproduction, making it accessible to all, regardless of biological limitations. Premature births could become a distant memory, with the ability to nurture and monitor fetal development in controlled environments. The risks associated with early births could be significantly reduced, ensuring healthier outcomes for both mothers and babies. However, this technology also raises complex ethical questions. What happens to the concept of motherhood when pregnancy is no longer a necessity? What are the potential psychological impacts on children who are not carried by a mother? These are questions that society must grapple with as ectogenesis moves closer to reality. The FDA is already taking steps towards regulating artificial womb technology, a groundbreaking innovation that could redefine the future of human reproduction. This technology, known as ectogenesis, involves growing a fetus outside the human body in an artificial environment. The implications of this are vast and complex, touching on medical, ethical, and societal dimensions. Paving the way for potential human trials, scientists are meticulously working to ensure the safety and efficacy of this technology. The research involves not only perfecting the artificial wombs, but also understanding the long-term impacts on the children born through this method. Interestingly, younger generations, particularly Gen Z, are more open to the idea of ectogenesis. They view it as a natural progression of technological advancement, one that aligns with their values of innovation and equality. This generation is known for its forward-thinking mindset and willingness to embrace new ideas. They see it as a way to empower women by providing more control over reproductive choices. Ectogenesis could alleviate the physical and emotional burdens of pregnancy, offering an alternative for those who may face health risks or other challenges. This technology also opens up new possibilities for diverse family structures, allowing individuals and couples who might not be able to conceive naturally to have biological children. It's a step towards inclusivity and expanding the definition of family. As we stand on the cusp of this brave new world, the potential for ectogenesis to revolutionize human reproduction is clear. However, with great power comes great responsibility. One thing is clear: ectogenesis has the potential to revolutionize human reproduction. The scientific community must navigate these uncharted waters with caution, ensuring that ethical considerations are at the forefront of this journey. It's a future full of possibilities, where technology and humanity intersect in unprecedented ways, but one that requires careful consideration and ethical debate. The decisions we make today will shape the future of human reproduction for generations to come.